Okay, testing, 1, 2, 3. Hopefully people can hear. We're live for the final virtual office hours for the POSA, or not the POSA, the Mobile Cloud Programming MOOC. And we'll wait a second and see if it's working. Looks like something's happening. That's good news. Okay, so welcome everybody to the final virtual office hours for the Mobile Cloud Programming MOOC. Hopefully you can hear me. And we will go ahead and start. In today's session, we're going to be covering our solution to programming assignment number 3. And this assignment has both a client and a service side, just like the other MOOCs that we'll be doing henceforth, including the Capstone project. So what I'm going to do first is cover the client side Android portion, and then we'll talk about the server side portion. As you'll see, the server side portion is much smaller than the client side portion. But of course, you built a lot of the server side stuff for programming assignment number 2. So let me go ahead and share my screen. We'll go find the appropriate browser that has the source code in it. There we go. That looks like the right place. And let us go share that. All right. So let's see. Here we go. Go ahead and make this nice and big. Hopefully everybody can see this. So let's just take a quick look first. We're going to go through the client side first. Let's take a quick look at the Android manifest file. Here's the manifest file. A couple things here shouldn't be too surprising. Typical SDK versions. We're going to want to use the camera if there's one, of course. Read and write to external storage, and use the internet. Nothing surprising there. We have an activity. One of the 2 activities we've got in the view layer, it's called list videos activity. This lists the videos, and it also does video uploading. And then we have the display video activity, which is used to either play and or download a video that's listed in the list of videos you get from the server. We also have a content provider, which is our content provider that we use to keep track of all the metadata associated with the videos that have been downloaded. And then we have a couple of services for uploading and downloading videos. Notice, by the way, that the display video activity is locked into portrait mode. I'll talk a little bit more about that later. And we do that just because the display looks goofy if you try to turn it and rotate it. Okay, here is the source code. As you can see, we organized the source code, as is our usual tradition these days, into a couple of different layers. We have the view layer, which deals with user interface interactions. We have the presenter layer, which is the middleman that sits and takes the user button clicks from the view and does stuff to it, and then gets data from the model layer. And the model layer is really what interacts with our content provider and also interacts with the Android content provider that stores videos, and finally interacts with the web data that's out there in our web service. And then we have the utils and common. Some of the common stuff is actually new and improved since earlier videos on this topic, and I'll be talking a little bit about that as we go through the examples. In particular, the generic activity is much cooler than it was before, and we'll talk about that as we go through. So let's start by talking about the view layer. We'll start with list videos activity. Here's list videos activity. So this is the activity that's used to upload a selected video to the video service, and it also displays a list of all the videos that are available at the video service. And you can use this activity to trigger the recording or getting of a video, either recording from the camera or getting a video from the gallery and uploading it. It plays the role of the view in the model view presenter pattern. It extends this generic activity, which we've extended a little bit to be much more decoupled than the previous incarnation. That basically allows us to be able to abstract away from the interface provided to this activity from the video presenter or videos presenter, which is the presenter layer object that provides the presenter interface or presenter capability to this activity. And then we also pass in the required view operations that are provided from this list views activity. And all these things are stored up here in a file. Let's go up one more level. There's a file called the MVP file, Model View Presenter file. And this is where we define all of the interfaces used by the various components in this application. And the purpose of doing this is to very strictly decouple the layers between the model view and presenter in the model view presenter pattern. And this allows us to change these things without affecting the code. I'll talk more about that as we go through the example. So just as an example here, what this is saying here is that there's a list videos activity, and it's going to provide the ShowGetVideoResults method to the presenter layer. And here's the presenter layer, and the presenter layer is going to expose the upload video method. That's the provided interface. So a presenter gets the required interface, which is how it can talk back to the view, and it exposes a provided interface that lets the view upload a video. And by using interfaces in this way, we don't have any strong coupling on the specific classes in our design. So they only need to export just exactly what they need to export, nothing more, nothing less. This, of course, means that the list videos activity implements the video's required view operations. We'll talk more about that. It also implements the loader callbacks interface, which comes from the loader manager in Android, and it implements an OnClick listener, OnItemClick listener, when you want to go ahead and upload videos. We have a request get video integer, which is used when you do the start activity with result method to get a video from the gallery or record a video. So this is how we indicate what the operation is. We have a super cool floating action button, which is used with the material design metaphor that Google's going now with Android M and beyond. And that allows us to be able to have a cool way of uploading videos. We have the list of videos that comes down from the server. We have a video adapter that can be used to basically show the list of videos in a list view in the activity. We have a factory method called makeIntent that returns an explicit intent that's used by the download video service to call back to this activity after a video has been downloaded. So you see how that works. Here's the OnCreate method. The OnCreate method has some new things here. First of all, we've split off the initialization of the superclasses bundle from the initialization of the generic activity, and that gives you more flexibility. That was a problem people ran into in a couple different ways. We'll talk about that in a minute. Here's how we initialize the default layout, which if you've watched the video of the solution will show you how all the pieces work. It's a really cool video that Chinmay put together. We initialize the views and view-related fields. We initialize the loader manager so that we can get the list of videos as they get updated by the video service. And then we turn around and we do another OnCreate method, and this one initializes the generic activity framework. And it basically says, here is the class that we want to use to implement this framework. We want to implement the presenter object that's associated with this view activity. And we're also going to pass in this view activity so that the presenter object in the presenter layer will have access to the required methods that it needs to call back when it wants to talk back to the view layer. And this is all very nice and decoupled. Okay, here's initialize views. We find the videos list by ID, which is one of the views. We find the upload video button by ID, which is also something that Chinmay did a nice job to integrate that into the layout XML files area. We set the OnClick listener, so if a user wants to upload a video, it'll either go to the gallery or the video recorder. We'll see how that works later in the DisplayChooser dialog. We create ourselves a new video adapter, which is used to display the list of videos. We set that to be the way that we display things. And then we go ahead and we set the listener that handles the event when the user clicks a video in the list view. So when the user clicks the video, they say, I want to basically do something with this video in the list. I want to be able to view its details more specifically, its metadata. Then this is what's going to handle that, this object. And we'll see how that works in a second. Here's DisplayChooser dialog. DisplayChooser is a really cool mechanism that Android provides where you can take a couple of intents. One that knows how to start an activity to get a video from the gallery one that will start the video recorder to record a video. These are just different ways of getting a video from the gallery and being able to capture a video using intents, very powerful Android mechanism, of course. And then we go ahead and we create a chooser intent that's going to include both the video gallery intent and the record video intent. So we put both of those intents into this other intent. And if you watch the video of the solution, you'll see that what happens there is that when we do the start activity for result with the chooser intent, Android pops up a little dialog box that gives us those two different choices to use to get a video, either getting it from the gallery or uploading it. So we start activity for result. When the user chooses something, as we'll see in a second, that comes back with the operation to, it calls back to the onActivityResult method, and then you can figure out what was chosen. Here's the onResume method. This gets called when we're coming back from being paused. We restart the loader. And here is the onActivityResult method. So onActivityResult, this gets called back after the user has selected one of the two choices. So if this succeeded and the request was get a video, we go ahead and tell the user we're going to upload the video. And what'll come back here, either because you got a video from the gallery or because you recorded the video, you'll get an intent back that contains the data portion, which is essentially what's going to be uploaded to the video. So what we do here is we talk to the presenter layer. We say, hey, presenter layer, please go ahead and upload the video. And here's the data that you need to get that video content that's stored by either the gallery or the video capture operation. So this is a good example of how the view layer talks to the presenter layer. Notice how it's very decoupled. And this is just one of the methods, of course, that's exposed in the provided interface by the presenter layer. Here's the OnItemClick. This is what gets called when a user selects a video in the list of videos. This is what they want to get more details on. And so what we do is we go ahead and get the cursor that's associated with the list adapter, and we move to the position in the cursor that corresponds to the button that the video that they selected. And then we go ahead and we grab the video ID from the cursor at that location. And then given that video ID, which is basically the ID that corresponds to the video that's stored, it's a way of identifying the video that's stored, or it's a video that we're going to upload. And we then go ahead and start the display video activity to, the video that we're going to display, not what we're going to upload. This is one we want to look at in more detail. And this video ID corresponds to something that's both on the local Android device and/or on the video service. That's an ID that's used to identify those things uniquely. And the video service is what actually produces this ID, so they'll be unique. And then we go ahead and we start an activity that will display information about the video that we selected. And we'll look at display video activity in just a second. But this is basically how we do that. Here's OnCreateLoader. When OnCreateLoader gets called, that's a callback that happens when we initialize the loader manager. And we go ahead and create a new cursor loader that's going to go and look in all the videos that are available in our content provider, our video content provider. And it'll basically give back the cursor loader that can be used to display the results that are in that particular content provider. And we have onLoader reset and onLoad finish. So when that thing is finished, when the cursor loader's OnCreateLoader is finished, it'll call back this hook method, and then we can go ahead and swap the cursor. So that will then update the display of the list of videos, which of course could be changing dynamically as we download videos from the video service. And then here's a method called ShowGetVideoResults. This is the method that's called back from the presenter layer back to the view layer to indicate what happened as a result of loading videos in an activity. So if we're downloading a video in an activity, this shows the result. We've downloaded the list of videos, and this shows what the results are. So if we succeeded, then it says that the videos are available. If we failed, it tells us that we aren't connected to the video service for some reason. And there's a couple of methods here for options. We don't have those implemented yet, but we'll get to those. All right, so that's the list videos and upload videos activity. And you can see how it interacts with the presenter layer, and it interacts with the videos presenter object, which we'll look at shortly. Here is the display video activity. This is what you are going to launch when you click on a particular video that you want to explore in more detail. It'll show the details of the video. And this particular activity can be used to play a video if it's already on the device, or it can download the video if it's not yet on the device from the video service, and then of course you can play it. This also implements generic activity, and the main difference between the list videos activity and display video activity is that this uses a different presenter. This uses the DisplayVideo Presenter, which of course has a different set of methods than the videos presenter. And here are the methods that are defined for that. If we look down here, we see we have the display video provided presenter ops. These are the things that this particular presenter will expose to that display video activity. So you can get a video by its ID, you can get a path to a video by its name, you can download a video, and you can add rating to a video. So those are the operations that the presenter exposes to the view layer. And then here's the thing that is required from the view layer by the presenter in order to indicate that the ratings have been updated. So these are bidirectional relationships that are handled very nicely using the model view presenter pattern and the generic activity framework. So this thing also implements the OnRatingBar change listener, which is an Android feature that can be used when rating bar changes, and you can subscribe to updates to the rating bar. And then it also, of course, implements the required view ops, so those can be passed down to the DisplayVideo Presenter. We're going to add some things to intents. We're going to put the video ID as an extra to the intent, and that's needed to download the video from the video service. That indicates to the video service which video we're referring to. And then we also have a download result receiver, which is a broadcast receiver that gets called back by the service once we've finished downloading a video rather, so we can know that we've got it. We have floating action button to play the video and one to download the video. And if you watch the video of the solution, you'll see how cool these floating action buttons are. They're really neat. And then we have an animation to fade the image in when the thumbnail of the video is loaded, just to give a little flair. We have the thumbnail of the video, we have the title of the video, we have the rating bar for the video, and then we have the metadata for the video that's being displayed by the class. We also keep the video ID stashed away here for certain things. And then we keep track of the path of the video in the local storage of the device if there is the video in the local storage of the device. And you'll see how that can be used to select between playing something from the local storage versus streaming it. Here's the make video intent. This is a factory method that's used to, the list videos activity uses this method to create an intent that will go ahead and start up the display video activity. And you can see it puts the video ID as an extra into the intent. So it says this video is what I want you to start. Here's the OnCreate method. OnCreate first initializes the bundle, sets the default layout, then it initializes the generic activity framework. We separate these things so that there's certain uses of things like action bars that require this to be done before you can use the action bar. So this new model separates those out. And we pass in the DisplayVideo Presenter as the ops, as the presentation or presenter layer instance, the object that implements the presenter layer for this particular activity view. And then we pass in the view here. And then we do a bunch of stuff. We get the video ID that was passed in with the intent from list videos activity. We hide the action bar. We initialize the views. We initialize the broadcast receiver. And then we get and display the requested video. And this, of course, may involve downloading things along the way if it isn't already available. Here's what we do to initialize the view. We initialize all those different view fields. We initialize the floating action button. We initialize the animation mechanism. We set the download video button to be null by default because that will only show up if the video isn't on the local device. So it's a real cool material design feature that stuff only shows up when you need it. And then here's the click listener for the play button, and that's an instance of something called Play Video Listener. So here's Play Video Listener, which is a click listener. And you can see what that does is it creates an object with an OnClick method. And when this thing is clicked, if the video exists on the device, then we go ahead and start playing it. So we're going to call the start video playing activity with the path name. Otherwise, we're going to go ahead and stream the video down from the video service. So we'll start the video playing activity, and we'll give the data URL that is what corresponds to the video that actually resides on the service. That wasn't strictly part of your requirement set, but we added it just because it's cool, and that's where it goes. Here's how you get and display a video. We go ahead and get the video by ID, which will give us the metadata from the video that we retrieve from the presenter layer, which actually calls that down into the model layer to get that from the content provider. We set the title of the video on the display. We set the ratings by taking the count, the ratings count, and the users who've rated it and getting the average. We set the listener for the rating bar, so that'll call back to us. We go ahead and get the path name for the video, if one exists, from the get path by name, which we'll take a look at shortly. And that might be null, of course. And then we go ahead and set the image bitmap. And we'll take a look and see what that method does in a second. Here's the onResume method. This gets called, when this gets called back, we're coming back from being paused. And we go ahead and create an intent filter that says we want to get the download video services intent. And we then go ahead and register with the local broadcast manager to receive that intent. And we use a local broadcast manager here because we don't want to expose this to all applications, just to this application. And it also makes it run faster. So we register this receiver, which we created earlier, and with this intent filter, and that'll get notified when a video has been downloaded successfully. Here's on pause. We simply go ahead and unregister the receiver because there's no sense in receiving those events when we're blocked. Here's the download result receiver. This gets called back when a video has been downloaded. This gets called back by the download video service. The onReceive method, as you can see here, extracts the status. Did it succeed or fail? Did the download succeed or fail? And then it also gets the received video ID. And if there isn't one, we just set it to 0. So it goes and looks that up. It grabs that out of the intent. And if everything went well, if the status was okay, and we got the video ID that we were expecting, which is the one the user selected, we go ahead and hide the download button because we don't need it, because we've downloaded it, we've got it successfully. And then we go ahead and grab the file path that we hopefully have at this point, and we set the image bitmap, and that goes ahead and sets a thumbnail of the video on the screen, and this is just how you do that. What we do here is we get the width of the screen, and then we check to see whether there's a file path of the video, if we have the video. And if we have the video, we go ahead and grab the thumbnail from the video, and we do this in the background. We create a new async task, and we run this thing in the background. And then when we're done, assuming we got the bitmap for the thumbnail, we then turn around and make that be the bitmap image, and we use an animation to fade in the bitmap. If the file path for the video is not present, then we're going to go ahead and enable the download button. And we're going to say, when we do that, basically, if you click that button, then the download video listener is what's going to be called. And here's the download video listener. When this gets clicked, you can see that it disables the listener for the download button, so you can't click it again until it's finished. And then we go ahead and basically put a real cool little download in progress icon in the floating action button. And then we call up to the presenter layer, call down to the presenter layer, depends whether you think we're at the top or the bottom at this point. And we say, presenter, please go download this video with this title. And that, of course, will talk to the presenter layer, and the presenter layer then uses the services in the model layer to actually do the download. And as we saw before, when the download finishes, it'll go ahead and send a result back by a broadcast receiver. Here's the start activity that we use to play a video. So once we've actually got the video and someone wants to play it, we just use Android's built-in support for playing videos. We use an action view, setting the data and the type to the video location. which is the URI in the file system where we've got the video, and here's the video that we actually want to play. And of course, since this is an implicit intent, we have to check to see whether or not there's actually a handler for this intent. Here's the callback that's invoked when the ratings change. So this is the listener when a user updates the rating. Then we go ahead, and if it comes from the user, we call the presenter to add this rating to the list of ratings that are stored on the service. And when that is done, a callback comes back from the presenter layer, and it basically tells us whether we've got the ratings. The ratings have been updated or not. So if the ratings have in fact been updated, then we're going to go ahead and pop a toast that says the ratings have been updated. If the ratings couldn't be updated for whatever reason, we say that too. And then we update the ratings bar to show the current rating of the video. Okay, so that's basically the way things work for the activities in the view layer. There's also a couple of other things here. These are the floating action button and the video adapter. We covered this. This was discussed when we talked about the video upload client. So I'm not going to go through those things now in the interest of time. They're just cool material design mechanisms. I think you have the source code for this that we talked about before. So these are just ways of doing the various floating action buttons in the video adapter. All right, let's go now take a look at the presenter layer. So as you can see, there's two presenters, one for the list videos activity in the view layer and one for the display video activity in the view layer. Let's start with videos presenter. So videos presenter implements all the operations related to listing videos on the video service and uploading videos to the video service. It plays the role of the presenter in the model view presenter pattern. And we implement generic async task ops so things can run in the background in the same class. And then we implement the provided interface that the videos provider provides. So this is pretty straightforward class. We have a weak reference to the required view ops that we get from the view layer. We have our generic async task. We have our video mediator, which is really the interface with the model layer. And the OnCreate method, as you can see here, this creates a new weak reference to the view. We create the new video mediator in the model layer. And then we start running an async task. And this async task will go ahead and basically load the list of available videos from the video service. We'll look at that in a second. Here's the onConfiguration change method. This gets called back when the activity is rotated. And keep in mind, the list videos activity can be rotated. The display video activity cannot be rotated, or will not rotate when you rotate it. The orientation will not change. So we just create a new view and stash it away here. So what we've also done in the generic activity framework is we've created an onCreate method, an onConfiguration change method, and an onDestroy method, which handle lifecycle operations for presenters. So we're basically, in the generic activity framework, we're basically creating a new component that's based on the MVP pattern called a presenter, which is something akin to an activity or a content provider or a broadcast receiver. It has a life cycle that gets managed by our framework. Here's the do in background method. As you can see, this runs in the background thread, and it goes ahead and gets and saves the video metadata. And you'll see how that works. That basically is going to be used to get the list of videos from the video service. And when we're all done, we call back to the view layer and display the result of getting that information from the service, whether it succeeded or failed. And then the final method that's here in this presenter layer is used to upload a video. And as you can see here, we go ahead and start a service, which is going to go ahead and run in the background and upload the video that's associated with this particular video ID. Okay, so that's the presenter layer. Let's go take a look at the other piece of the presenter layer. It's the videos presenter part of the presenter layer. Here is the display video presenter. This is what's associated with the display video activity. So this is the V and the P portion. This is the P portion of the VP relationship in the MVP pattern. This also implements generic task ops, so we can run things in the background. and it implements the provided interface from the display video activity. Whoops, and then, whoops, this thing should be zapped. That no longer belongs there. I'll delete that. Forgot to get rid of that. It's not used anymore. Here's the display view weak reference we use to talk back to the view layer. Here's our generic task. We also have a mediator again. We keep track of the video whose metadata is going to be displayed. Here's the OnCreate method. As you can see here, it just stashes away a weak reference to the view and creates the video adapter, or so the video data mediator, which of course is going to be the model in this whole thing. Here's the other lifecycle methods. They're not really interesting at this point. This application cannot be rotated. This activity cannot be rotated, so there's really not much to do here. This method should never be called. Actually, we could probably just make it a no-op. So here are the methods that this thing exposes. This gets the path of a video in local storage by the name of the video, and it uses the video media store utils, which we talked about before, to go ahead and get the path name that's associated with this video, if there is one. We can get the video by ID, which talks to the mediator, which gets the video metadata associated with that ID. We can download the video. As you can see here, download starts a service, which is the download video service, which will download this video ID with this video name, and it stores it, of course, once it's finished downloading. We can go ahead and add rating here. And when we add a rating, we take the video ID, we start a new generic async task, we stash the video ID locally, and then we pass the rating that the user has given to the task. And what that does is that turns around and calls to the video mediator, which talks up to the video service in order to add that rating. And when it's all done adding the rating, then we go ahead and call back to the view layer and say, update the rating. And of course, the view layer is what's responsible for actually updating the widget on the screen that has the different stars for that video. Okay, so those are the presenters. You can see that they are actually pretty straightforward. The presenter layer in this case is really just coordinating interactions from the user interface with interactions with the model. It doesn't do a whole heck of a lot more than that. Here is the model. The model is divided into two parts, the mediator and the services. Let's take a quick look at the services. They're very straightforward. The services, there's an upload service and a download service. And then there's a common file that factors out functionality that's common to both uploading and downloading. The video service common is an intent service, so it'll use the intent service model, so it has a background thread that runs. This keeps track of notification ID. If you watch the video of the solution, you'll see that when videos are uploading and downloading, the notification bar is got a little cool icon that indicates the direction of the uploading or downloading. And you can actually go to the notification bar and pull it down and see what's going on in terms of the progress. So that's all done through this notification ID through the notification manager. We have an interaction with the video data mediator here. We have our notification manager. Here's our constructor, which initializes the intent service. The OnCreate method gets ourselves a video data mediator and gets ourselves a notification manager. And then we have a couple of methods, make notification, which basically creates the notification bar icon with the information it needs using a builder, makes a notification. And then we can also make another one for the there's a couple different ones that we do here, one for uploading and one for downloading. So these things can be used to make different kinds of notifications based on what we're trying to do. So let's take a look here. Here's uploading. We'll look at that one first. So you can obviously take a gallery picture or you can record a video, and that'll end up calling the upload video service, which is called by the intent that's created here with the make intent factor method, which we always do. This makes an explicit intent that we'll call the upload video service for this video URI, which of course is stored on the local device. The onHandle intent method starts a notification. We'll see what that does in a second. Then it goes ahead and talks to the video mediator layer to upload the video. Here's the video we want to upload. And then when that returns, it calls finish notification. Those just update the notification bar. Start notification, as you can see here, makes a notification which says we're uploading the video, since it's the upload service. And then when the finish notification gets called back, it goes ahead and basically changes the icon and says, hey, we're done. We're done with the uploading. So you can see, very short, very concise. That's the way almost all the pieces in this application are. They're all very concise. That's uploading. Here's downloading, also very concise. It implements or extends the Video Service Common class. Here's the action we're going to use to send the broadcast to the display video activity. You saw how that worked earlier, that when a video is downloaded, we want to broadcast the fact that it's downloaded to the specific activity that will then handle that and know that download has succeeded or failed. Got some status codes we use to keep track of the results of the downloading, keep track of the key path for the file, for the broadcast receiver, and the status. Here's the key of the video ID that's passed as an extra to the intent that's used to start the service. We also have the title that's passed as an extra as well. Keep track of the video ID and the video title. We use that for various purposes here. Here's the make intent method. As you can see, make intent is a factory method that will create an intent that can be used to start the download service, putting the video ID and the video title of what we want to download into the intent, so it's got that when it starts. Here's onHandle intent. This gets called back, of course, in a background thread. It extracts the video ID and the video title. So we got those two pieces of information. We then start the notification, which updates the notification bar. We go ask the Mediator to download the video with the video ID and the title. And this then goes ahead and runs. This runs, it's a synchronous call to the video service, but that's okay because we're running in a background thread in the intent service. And when that returns, it'll give us back the video file path. If the file path is non-null, then we've successfully completed, and we broadcast to the activity, the display video activity that we successfully completed, and we give it the path name where it can find the result. If it didn't download the file, we indicate that as well, and we send back an error result through the broadcast. Here's send broadcast itself. We create an intent, and we put the various keys that we want to have in here, the status and the video ID. And then we take that information and we will create an intent from it. We put in the file path if we got one. And then we go ahead and send the broadcast via the local broadcast manager, which goes back to the display video activity to indicate how the download has happened. Here's start notification. Start notification is interesting. When we start doing a notification, we create a pending intent, and this goes into the notification bar. And once the thing is downloaded, then you can click on that, and that will take you to the list video activity. So get that, and then finish notification just says that the download is done. Okay, so that basically is the services layer. Let's go look at the Mediator, the services portion, I should say. It's not really a layer, the services portion of the model layer. Here's the Mediator layer, or Mediator portion. It has the video data mediator, which is really the interface to the model in this particular application design. And so this is a video data mediator. It has various strings that are used to indicate success or failure of the operations for uploading and downloading of files. It keeps track of a video service proxy that can be used to talk to the video service that runs in a server somewhere. We keep a weak reference to the context for various reasons having to do with how we access certain resources. Android, unfortunately, makes things a little complicated on our part because of the tight coupling between model view and presenter functionality in the activity class. But we can separate those if we're careful by using the MVP pattern. Here's the video cache. The video cache is just a front end to our content provider that makes it a little higher level and easier to use. Here's the constructor for video data mediator. We make a weak reference to the context. We make the video cache, and then we create the retrofit proxy, which can be used to talk to the video service. Here's download video. Download video, keep in mind this gets called by the download video service. This goes ahead and talks to the video service to get the data about the video ID. So it basically gets the metadata about that. And if we get it successfully, then we go ahead and we store that information into the downloads directory. We store this so that it'll be there so we can use it later. And we give back the absolute file name, the absolute path name of the video file that we've downloaded. So that can be used later when we want to play the video. Here's upload video. As you can see here, upload video. We'll go and get the path name to the video that's on the device. We go ahead and get the video metadata from this path. So now we have the video metadata. And then if we got the video metadata, then we go ahead and create an instance of the file that we want to upload, and we check to see how big the file is. If the file is too big, we won't upload it. It has to be less than 50 megabytes. That's just a decision that we have to keep from swamping the network. Obviously, you could make that a configuration parameter if you wanted to. And then we go ahead and add the metadata to we send up the metadata to the video service. And this is a blocking two-way call. So this, of course, has to run in a thread, which it does in the intent service. And this gives us back the metadata that the video service has updated. And inside that, if we get that back, we get the video ID, which is the unique ID that's on both the service and on the content provider of the local capability. And then we go ahead and we create that information and set the video data information. And we also go ahead and we'll provide the content in the video file that we're going to go ahead and set the data portion. So we're actually going to upload the content here. So the first part basically uploaded the metadata, and the second portion uploaded the content. And I think that's why we use the multi-part mechanism in the service. And then if everything worked out, then we go ahead and insert the metadata into the video cache, which actually turns around and updates it in our local content provider. If things went awry for various reasons, if the upload failed, the file was too large, or something else went wrong, we return strings that indicate what happened. And those can be used as error messages. Here's the get and save video metadata method. This gets the list of videos from the video service and saves it in our video content provider. So you can see it goes up to the video service, says, get me the video list. That comes back as a list of videos, which is really video metadata. And if it worked, we go ahead and insert that metadata, all those video metadata into our video cache, which puts it into our content provider, so it's available for browsing, and return results. Here's how we add ratings to the video. We go ahead and tell the video service we want to update this video with this rating. And assuming that it found that video, then we go ahead and insert the updated metadata into our video content provider. So what we're doing here is we're both updating the service and we're updating our content provider to have the new results. And that just speeds things up later when we want to know what the ratings are. And then finally, here's a get video. This is just the method that gets the video metadata from the video content provider given a particular video ID. So this is just a local call. It gets it out of the video cache. So speaking of cache, let's go take a look at the provider. So the provider has the cache, and the cache is just a front end to the content provider just to make things a little easier to work with. So you can insert a video into the content provider. You can insert all the videos into the content provider using a bulk insert operation. This should look very familiar because it's almost identical to the other examples we've used from weather service and so on. Here's how you get a video by ID. You look up a particular video ID at the appropriate location in the content provider and you query it and you see what you get, and then you make a video metadata based on the cursor you get back. You can get all the videos, which will give you back an array list of the contents that are stored here, and so we query the entire content provider, and then we go ahead and add that content into the array of videos. Here's how you get the content values. So this gets the video ID, which is that unique value, the title, how long the video is, what type it is, the URL on the server, video service, the rating count, and the user count, which are used to compute the average for the ratings. Here's how you do get video. As you can see here, we go ahead and we have a cursor and we extract out all the various fields, all the various columns from the cursor that we get, and then we make a new video metadata object that has all those values in it. So that's kind of the front end to all this stuff. And then the other parts here are really just very straightforward. There's no real surprise. This is just the way we access the video content provider. This is almost identical to all the other content providers we've done. It's laid out exactly the same way. The only real difference, of course, is we just have different content here, the various fields, or rather the columns that we've got, video ID, title, duration, and so on and so forth. And the database helper, nothing surprising there. It looks like a normal database helper. Here's the SQL for creating the table that's going to use to store the information about the videos. Again, no real surprise there. Video content provider, as you can see, it basically is going to be used to actually access the SQLite database. No real surprise here. We insert stuff into the database. We bulk insert things into the database. This is all the content, the metadata about videos are inserted into the database. We can query the database for all the videos or an individual video. And we can do updates in the database, and we can do deletes. So really no real surprises there either. Okay, so that I think is basically a whirlwind trip through everything. We also have some utils, but these utils are basically the same things that we had before. So I'm not going to go through them in detail at this point. We covered them in the video upload client. All right, so I'm going to take a few questions, and then Jules is going to present the server side. So let's go ahead and start, see what your questions are. The rule for the rating, sum divided by count, shouldn't that be in the server? You're welcome to put it wherever you want it. That's up to you. This is the way we did it, but you can do it some other way. There's no problem with that. That's the reason for having a mini project with lots of flexibility. Let's see. Can you give us some tips on how to rate the apps of our peers? I saw big differences in the screencast. Well, please read the instructions. So you need to go and look at the rubric that's in the peer assessment page, and make sure that people have done all the things that they are required to do in the requirements in the index.html file. Model. Let's see. Model. Retain fragment without visual element. View all fragment with visual elements, and the activity is presenter, which does only mediate between models and views. Not quite sure what you're asking. That's obviously not what we're doing here, so I'm not quite sure what you're asking. Let's see. Does our solution use the new app compat library for material? I don't think so, but you're welcome to take a look at the video and see, or post that to the news group or to the discussion forum, and we'll look into it some more. In the broadcast manager for the download service, you have to make an intent to report back. I noticed the intent set data canceled out the receiver while setting the put extra. I'm not quite sure what you're asking, app. Why don't you go ahead and post that on the discussion forum? The one thing to remember is if you use set data and type, that overwrites, or sorry, if you use set type, that overwrites the data for some very, very strange reason. So you have to use set data and type. So why don't you take a look and ask that question? I'm not really sure what you're asking. I don't have time to go through it right now. The structure, MVP, are a common approach for organizing apps in Android. Yes, absolutely. If you want to learn more about using the model view presenter pattern in Android, just go to your favorite web browser and type Model View Presenter Android, and you'll find a whole bunch of links that talk about using the Model View Presenter pattern in Android. And yes, it's used very widely in production projects. It's a very, very convenient way of organizing things, and greatly simplifies the design of the program, separates concerns, makes it easy to mock things up for testing purposes, makes it trivial to handle configuration changes when you rotate your phone, etc., etc., etc. There's all kinds of goodness that comes from this. The decision in the beginning of the project to have two different server processes, one to upload video metadata and another to upload the real video, is just for better understanding, or is there another reason to do that instead of doing just one? That's probably a good question to ask to Jules when he talks about, when he comes here in a second. So the rationale, I think you're really talking about multi-part uploads, where you upload the metadata and then you upload the real video data. I'm not sure if that actually ends up having two different server processes, but he will know. So I will leave that question here for you. The support for MVP by Android bets much better if you're using fragments. I wouldn't be surprised about that. During this MOOC, we use MVP to organize the project structure. Are there any other good models, patterns to organize projects that you can suggest? Can you share some links? I'm a big fan of MVP. I'm sure that there are other ways to do things. If you want to do it a different way, please feel free. That's the way I like to do it, and I found it to be very effective for separating concerns. I used to do it some other ways, but I found that they were very ad hoc, and it drove me crazy. And if you read a lot of Android code, you'll see it's done in a very ad hoc way, unfortunately. As I understood, Presenter used for saving the state of application. I wouldn't say it's used for saving the state of the application. The Presenter is used to be the business logic layer that mediates the interactions between the view and the model. The model is typically where the state is saved in a persistent way, or it's obtained from a server, like a video service. The Presenter doesn't really store the state persistently. It just allows the state to persist across runtime configuration changes in the view layer, which is one of the headaches that you get in with Android that is done, that is solved much nicer by using the model view presenter pattern. Again, you do not have to use the model view presenter pattern. If you don't want to use it, you're free to do something else. That's not part of the requirement set. Why did you not use the ID passed to OnClick method when a list item is clicked? I'm not sure why. We didn't need it, but if you needed it and it worked for you, feel free. That's fine. I use a static member in the show video activity to pass parameters from the list activity to the show activity. Is this a good approach, as we only have one instance of show video activity at a time? I tend to try to avoid using statics to pass information between activities. That's kind of a hack, and so I would not recommend it, but that would not be my choice. Let's see. Is there a point where a high level of normalization of code reaches a diminishing return in terms of performance functionality, only adding more complexity? More pieces of code not equal to better functionality performance. The amount of code you have, I'm not quite sure what you mean by amount of code. I think what you're really asking is the degree of abstraction that you have, not so much the amount of code. The amount of code is typically the same. It's just rearranged in a larger number of smaller sized classes if you use abstraction, or a smaller number of larger sized classes if you do not use abstraction. There really is almost nothing, there's really almost no relationship whatsoever between degree of abstraction and performance in a modern environment, especially if you're careful with your concurrency architecture. So I don't think it's really much of an issue at all in practice these days. It's the least of your worries, let's put it that way, in Android development. In the earlier videos, I used a UML design tool that was called Object Aid. And if I'd had more time today, I would have shown you the design of everything with Object Aid. I don't have that time, that luxury of time, unfortunately. Let's see. Okay, well, I think that is it for the questions related to this part. I left the question up there for Jules about the server processes, and now I'm going to switch over to him, and we will talk about the server side. Get that.
All right, we're gonna
let's say, so let's go to here and there.
perfect.
And there, and oh yes, and let's all right. Here, hold on, let me make that a little bit more easy to read, so that way you can see questions as they come in. Okay, there you go.
Great. So we're going to walk through the server side of the solution, which should have been a depending on how you did it, a minor update to the original server that you saw before for the previous assignment. This time, depending on how you implemented it, you could have used JPA, and you could have done it different ways with Spring Data and JPA. And so it really just depends on your particular design. So I'm going to show you first an example of how you would implement it with Spring Data JPA, and then we believe that some people probably were confused. We were hoping that people would use Spring Data JPA, but we realized that in the project requirements it wasn't 100% clear that we were looking for that. So it's also okay if you just did this with a POJO object that was stored in map before, although that's not the preferred way to do it, but for pure grading purposes, we should give that credit. If you use Spring Data JPA, you would have taken your video class, you would have added @entity to it, and you would have added an ID to it that would have been auto-generated. And then you would still have the other fields if you wanted to have those. And then the key thing that's going to change is you're going to add fields for ratings. And there's lots of different ways to do this. You could do this the really complex way, where if you were getting lots of traffic, you would want to do something like a sharded counter, like was described in some of the videos. But in this case, we're just going to show some simpler solutions to doing this, since the goal was not to create YouTube and the YouTube rating system, which obviously has to be at a completely different level, but to just show some simple examples of how you might implement this with Spring Data JPA. So one way you could do this is you could have a rating and total ratings set on the object itself, and at each time a rating comes in, you could update the average rating, which is what you're storing. So you're not actually storing the individual ratings, but you're just storing the average rating and the total number of ratings that have come in case that information is helpful. There's other ways you could do it too, where you could store the individual ratings. So one example is if you wanted to have each individual rating that had ever come in, you could also do that this way with an element collection. So there's multiple ways that you could go about annotating these things with ratings data. Now, one of the interesting things that we specifically chose ratings because they seem simple, but to do them correctly, particularly for applications like an application like YouTube that gets an incredible amount of traffic, you really have to think about how you implement it, because a simple thing like this can get really complicated and become a bottleneck in an application due to locking and other issues if it's not done correctly. In this case, we're just looking for a simple implementation. So either one of these approaches would have worked. If they didn't use Spring Data, let me go ahead and refresh this page. You would want them to have some type of atomic long or some other atomic way that they were counting ratings. And this is for if they did not use Spring Data to JPA, because then they're responsible for their own locking and issues related to that. So in this case, they could take an atomic long and increment it if they were using the original in-memory approach with POJOs. You would expect something like that there. We'll go ahead and take a look at the controller now, which is fairly simple. Actually, we'll take a look at the repository first. So if you did Spring Data JPA, you should probably have a repository that looks like this, a CRUD repository. We've added some other examples here of other methods that you could add to do querying. So if you wanted to find videos of a particular kind, you could add those methods to the video repository, although it's not required. Now going back to the controller, we've implemented a whole bunch of different methods here, but we're going to focus on the ones for ratings. So what we've done is we've created a new controller method to accept a rating for a video, so you can post a rating to a particular video's ID to add it to the video. And depending on how you went about implementing this, you could actually, this is wrong right here. I was trying to show multiple versions here, and I've got it messed up, but the calculation of average is incorrect here. I just realized that I had some two code segments messed up. But you would want to do something like getting the value and calculating a new average, and then setting it along with setting the total and updating the video. If you're storing all of the ratings, what you would want to do is just add the rating to the list of ratings that have been provided for that video. Now, obviously, for all of these examples, we're assuming that we're dealing with an application that's getting very low traffic, very few numbers of ratings per video. So you had lots and lots of ratings per video. Obviously, both of these implementations and approaches would be, not scalable, more than likely. In both of these cases, Spring is going to automatically handle underneath creation of a transaction. We don't see it here, but it is possible that when we go to save this, an exception would get thrown saying that you went to save it, but somebody else had actually updated it while you were doing this. So if you had high traffic, you would have to start thinking about handling contention on the database and other things, but we didn't cover that in the class, so we don't expect you to have handled that. And then for our example, you don't have to do it this way, but we just created a simple video rating object in order to return the rating. So every time a video gets updated, we return the new rating to the rater. And every time somebody asks for the ratings, we create a video rating object and return it with some metadata. So actually, I think I described that wrong. The rating is the total of the ratings divided by total number of ratings. So when I was saying average rating on video, that was my mistake when I was describing that. It's actually the total rating value, which has to be thought through. One other thing to look at is I'll just show you our implementation of video rating. This is just a simple object that we're using to return metadata about the ratings, the video, the rating, and the total ratings. There's lots of different ways you could have gone about implementing and tracking the rating. Lists of ratings. Our TAs came up with a couple different ones. We've tried to condense them all into one set of files here to show them to you, with Pojo and in memory, with JPA, using an element collection, with using variables on your video. All of them are okay ways to do it for the assignment. If you were doing if you were doing a really high traffic website, you'd have to think through the design and do something like a sharded counter. All right, with that, I'm going to go ahead and turn it over for questions, and I'll open up a floor here. So start off with, there is a retrofit interface on the client as well on the server. It's obligatory that they're identical. It's obligatory that the interface that they describe from an HTTP point of view is identical. So they don't have to be the same file. They don't have to use the same method names, but the annotations and the way that you annotate the methods has to produce HTTP requests that the server is going to understand. So from the point of view of client server, they need to be identical, and from an HTTP perspective, the server has to support the HTTP methods and parameters that the client interface is going to produce from the annotations. Can you explain how the amount of traffic influences the way we implement the rating property in the video? Sure. So let's imagine that we are YouTube and we have the Gangnam Style video that was, I believe, the most popular video ever on YouTube. So this video might be viewed simultaneously by, let's say, 1,000 people, and maybe it's being rated simultaneously by 1,000 people. So if you try to implement this with a single, let's say, variable on our video object that represented the current average rating, or a single variable to represent the total number of ratings, and you had 1,000 people simultaneously trying to update that value, what would happen would be you would have 1,000 different entities trying to concurrently lock that entity in the database so that they could update it. And what you would end up with is an incredible database contention over that one row and one column in the database. And so it would end up grinding your system to a halt, because you would have all of these people trying to write to it simultaneously, but they're essentially, rather than being able to do the writes in parallel, they would all be writing to it at the same time. Ways to avoid that: one way is if you had, let's say, you wanted to store each rating separately, so you could have a video rating object that you were storing instances of it in the database, and you could have a key. For example, the video rating object could have an ID of the video that it was a rating for. So in this case, every time a new rating came in, you could simply add it to that table, and there would be no locking contention, because essentially all of the writers could come in and add their ratings simultaneously without affecting each other. But when you wanted to go and display the rating and the average, you would then have to do a lot of work, because you would have to fetch all of those rows from that video ratings table, get their values, average them, and then return it to the client. So that's where things like sharded counters come in. So what you do with a sharded counter is you take the counter, and if you watch the videos, it's described in detail, but basically you have multiple counters for a video's rating, and then you essentially randomly choose one when you're rating, and then when you want to display the rating, you have to sum up across all of them and recalculate the rating. So there are ways to do things like that, but the more essentially people that you have rating simultaneously, it creates write contention. So if you have a single variable on a video, it could be an issue. Let's see. Can you discuss the implications of storing metadata about the client and the server? What happens if they get out of sync? Yeah, synchronizing between the two is out of the scope of this. It's certainly something that you have to consider, and it's really, on an application by application basis. It's a very, very hard problem, and there's different strategies of handling it. You can have strategies like that you assume that the client is always right. You can have strategies where you assume that the server is always right, and whatever order the server sees things in, you can decide that that's the order that it happened in, and then force clients to deal with that. There's a lot of complexities to doing it and doing it correctly, and a lot of the decisions on how to do it correctly are based on each specific application and the requirements. Okay, string, hibernate drop table video if exists. I'd put it in application. It's not clear what you mean by this question. If you can post that in the forums, we can follow up on it. I've tried to use JP as explained and haven't been able to persist the data across server restart. I think the problem is I have the setting spring data update has not taken effect because the console showed the string. Again, this is something to post in the forums. There's probably needs to be a little bit more detail that we can follow up on to understand. You're trying to set the, I'm guessing the H2 database settings so that it persists across restarts. There's a post that describes how that's done that I made. That's in the forums if you go and search for it. But if you post also, we can help you out, but we need a little more information. Let's see. So I understood client and server should use the same POJO, should be moved into a separate project and used as a library and used in a server project and client project, or the other ways to reuse code. Yeah, so there's different ways to do it depending on what you wanted to do. Lots of different ways you can structure this. One way to structure it with Gradle is you can have Gradle projects that link to each other. That's possible. If you're using Gradle, it's also possible to have a project that you publish to your own local repository. So every time you build a version of it, you can publish it to your local repository. And then, for example, your client or your server could, as part of its build and in your dependencies of your Gradle script, could link to that dependency and pull it from your local repository. You could also push it up to a remote Gradle repository somewhere. It's a little bit out of the scope, but if you go and take a look at, I'm trying to think, I don't think there's any of the examples that do this, but it's certainly possible to either have Gradle projects and builds that link to each other and refer to each other. There's also the possibility of, again, publishing it to a local repository or remote repository and then just adding it as a dependency to either the client or the server or both. So if you have it extracted into its own project, all of those common files like, model or something like that, like video model might be your project. You could publish it to your local repository and then have both of your client and server depend on it. Or you could have a separate project and have them both refer to it in the build. And those types of things you can take a look at the Gradle documentation describes how to do that. The decision in the beginning of the project to have two different server processes, one to upload the video metadata and another one to upload the real video data. Just for better understanding, is there another reason to do that instead of just one? One is to obviously give some separation and show more things. Another is because if you use a cloud storage service like Amazon S3 or Google's Blob Store, and you have your application is going to be running and probably storing the metadata in its own database, but all of the binary data for the videos is going to be stored in S3 or a Blob Store. You end up having to do it like this because the reason is that you first have to upload the metadata to the server so that the server can return to you a pre-signed URL that you can go and upload the video to. And I don't cover pre-signed URLs in the cloud class, but what that is essentially you don't want to hand over your credentials to Amazon, for example, or to Google in order to allow one of your mobile clients to upload a video. So what you do is they have special APIs where you can create a URL that you return to just that client, and it allows them to do a single video upload or to upload over and over to that video, but not to access anything else in the account. So by having this two-step process, it allows you to support having an external storage system like Amazon S3 or Google Blob Store, where you would first upload the metadata to your server would return the URL to Amazon S3 or the Google Blob Store, where you would upload the binary data to have it saved. What is the best way to implement a Spring Boot service on a real service? I'm not quite sure what you mean by a real service. If these are the right ways to implement Spring Boot services, and you can go and look at the examples repository for more examples. This is how you go in and build things. It's what you mean by real is a little unclear, but you can also go and Google around and look at some of the Spring Boot examples that they provide as well. All of them give you a sense of how to do things, but what you mean by real, what the difference between what you're doing in real is primarily the requirements of what that real thing is and the changes that would have to be made to support those requirements. I had lots of problems with retrofit library packages conflicting with internal Android Bean libraries for the Android app. I'm not sure what the exact conflicts you were having. If you can post that in the forum, that's probably something that's better for the forum, and Doug can try to follow up on that. Retrofit should work with no problem with Android. So I would also take a look at the retrofit forums. Just Google around for the exception you're seeing, and hopefully you might see some information there too. My guess is that somehow you're accidentally including the wrong dependencies or something along those lines. You mean that Pojos anyway should be moved into a separate project if you want to reuse code? They can be moved into a separate project that's shared by both in order to make it more reusable, and that's a good way to do it. But you don't have to do it that way. You can also, have one project depend upon the other. That's certainly possible as well. And then you would still be able to reuse the code from one project and the other. You can split it all. Again, you can refactor the model out into a separate. You can refactor it out into a separate project. That's certainly possible. That works. You can also publish jar files that you build that would be used in one project, although that gets a little trickier to keep it all in sync. But all of those are possible options. All right. Well, I think we have come to the end of the questions. So thank you so much, everybody. And we've enjoyed having you in this MOOC. This will be our last live office hours. And, hopefully we will see you in the next MOOC. And, we will enjoy following up with you on the live lectures there when we start in a little over a week here, I guess. Thank you. Actually, I guess it's probably closer to 2 weeks. All righty.